Let's take a look at some of these. I mean, there couldn't have been that many ways to do the first four problems. Absolute value equations, there's one way to really do it. All right, so for example, if you look at number 1b, so what's the very first thing to take care of in that one? What's kind of in the wrong place?
The -1.
Yeah, that -1. So I gotta add that over, isolate the absolute value. And then what's the idea I can use? The next step is like a conceptual step. I'm not going to do something to both sides. I'm going to rewrite what this means. The absolute value of something is 5. So either that something is 5 or -5. And really, just let that make sense. What do I put in here to make it 5? I can make this 5 or I can make this -5. Okay. So either 3x plus 1 is 5 or 3x plus 1 is -5. All right, so I think the first four problems is really just one way to do it. I think the issue came in with the second set of problems, with the inequalities. Right? So if we finish this out, subtract 1, divide by 3, is that all right? And in this one, you would subtract 1, divide by 3. And you can plug them in and check. Right? So if you plug in 4/3 times 3 is 4, plus 1 is 5, minus 1 is 4. If you plug in -2 times 3 is -6, plus 1 is -5, but the absolute value of -5 is 5, minus 1 is still 4. Right? I like it. You guys okay so far? So, I mean, if I said the absolute value of something plus 2 is 6. Well, what plus 2 is 6? 4. So then whatever's in here has to either be 4 or -4. So if there was a 5 minus x in there, well, okay, 5 minus x has to be 4, or 5 minus x has to be -4. Right? That's why we isolate the absolute value first, so I really see what number that thing has to be. And then the inside could be that or negative that. Because after I put in the absolute value, they both come out the same. Right? The absolute value 3 is the same thing as the absolute value -3. Maybe. That's why there's two cases, because there's two ways to make, in this case, there's two ways to make a 4 from this. Either it's 4 inside or it's -4 inside. They both make a 4 at the end. That's why there's two cases. How we doing? You guys all right? You guys look. Yeah, I'm okay. All right. What's up? Is that right? And then, I mean, if you solve this, -5, -x, and so x is 1. Sure enough, 5 minus 1 is 4. And then here, subtract 5, divide by -1. 9. 5 minus 9 is -4, but the absolute value makes it 4. So then it still works. How's that? You guys all right? You guys don't seem all right. Okay. You guys vote yet?
Yes.
Yes? All right. It's okay. If you don't want to vote, it's totally your option. But that is really, really, really silly. Holy shit. Okay. So like this one, 2A. So either it's going to be the one I can write with a ceiling and a floor, that's sandwich, or it's going to be the one I have to write this or that, the restraining order. Stay away from it. Which situation is this? No, it's 50-50 shot. So this is saying the distance is less than something. So this has got to be, the distance here has got to be less than 2. So either this can go up to 2 or it can go down to -2. No, we don't like that. Yes?
Wouldn't that be a or?
No, it wouldn't. It's an and. And I hate... All right. So this is one way I could teach this, and I don't like teaching this way, but less than is an and. Greater is an or. What do you think? Yeah. Greater. Just misspell it. No, yes. Greater sounds like some weird ass robot in some old cartoon. Like Greater. Or not. I hate the idea that bless you. You could write this like this and x minus 5 greater than negative 2. That's completely fine. That is totally true. But it makes it seem like it's more work than it really should be. If this has to be less than 2 and greater than negative 2, then why not I just write it like that? This says it's doing both, right? You have to be less than 2 and greater than negative 2. Yes?
Well, why do you put the negative, or how do you know intuitively like that it has to be like negative 2? That is like that it has to be like greater than.
All right, so here, let me show you something.
Is that because like of the absolute value?
You ready? So, all right. There's a reason why I teach this a certain way. But to be honest, I almost always end up showing you what I'm about to show you anyway. So maybe I'm going to incorporate it in there anyway. Who remembers what this was? I think I asked this to you before. Remember this? What was this?
X.
It was x or negative x. Right? It's two different things. So either this is itself or it's the opposite of itself. And then if you divide by negative 1, what happens over here? I mean, that's really why the two cases are the way they are. And then if you read this, what's it say? Negative 2 is less than, see that? If I read this backwards? Negative 2 is less than this, which is less than 2. So every other way to do it will lead you back to this. And the reason this makes physical sense is because this is distance. Can't be more than 2. It's got to be less than 2. So if I'm standing at 0 and I'm like, please don't get further than 2 away from me, how far up can you go?
2.
To 2. And how far down can you go?
To 2.
To negative 2.
Or to 3.
That's what this says. Here I am in the middle. You can go up to 2 and down to negative 2, but then you're staying close to me. Why does close make sense? Less than. I want the distance to be less than something. Don't get further away from me than 2 or negative 2. So let's do this. Let's do like a lightning round of this. So if I had 2x plus 3 less than or equal to 7, how can I rewrite that in one statement with no absolute value?
2x plus 2 greater than or equal to 7, and then less than.
Yeah, so that's between negative 7 and 7. Yes?
But you can't do it the other way, just like that.
What do you mean? How do you mean? Sorry. This way. Yeah, this way works. You just have to remember it's an and. It's got to be this and this. Less than for and. Yeah. So you could totally do it this way. That works. It's just much more useful later on with more math that you have to take to get used to writing this bam like that. It just gets to the point a lot quicker.
So for the example you showed, why
Yeah.
don't you flip the sign for the negative 7?
Totally did. I totally did. This says this is less than 7. This says negative 7 less. I flipped it. Do you see that? I want you to really realize something. Did I flip the sign here?
No.
No, I didn't. So, did I flip the sign here? Yeah, I totally did.
The substitute explained it yesterday pretty good. She said the open side, if it's towards something, it stays towards that thing. I can't explain it very well because I'm not able to articulate it, but so like the open side is towards the +7 up there. When you write it in that string sandwich sort of deal, make sure the open side stays towards the +7.
Oh, sure, okay, sure. Yeah, one case is always, if the thing on the inside was already less than 7, then it makes sense, right? Or if the thing on the inside is greater than -7, like -6, and then it still makes sense. So sure, there's a lot of, the reason I don't like the less than in the Great Tour is the more you do that kind of thing, the further you get removed from the math itself. The more you think those are necessary to understand math at all. And then you start to depend on those things. You'll have students say, well, don't you have a little song for this? Or don't you have a little, every good boy does fine, or something like that for me, FOIL, F-O-I-L. I'm like, you don't need that shit. Get to the idea of it. So if I have a less than, that is a stay close to me. You see, the minute I do that stay close to me, I get the sandwich idea. It's got a floor and a ceiling. And then solving this isn't too bad, right? How do you solve this?
Subtract 3.
Yeah, subtract 3 from all sides. And then divide by 2. And what's really beautiful is if you put it like this, you can see that the answers are between -5 and 2. So then the picture makes complete sense. Right? It really just puts it in your face that the answers are between those. That's exactly what the picture looks like.
Wouldn't it be parentheses, not brackets?
It's allowed to be equal to, so
Oh.
yeah.
So that would be an and.
That would be an and. Yeah. So the other way to solve that problem, if you wanted to, you can say 2x plus 3 less equal to 7 and 2x plus 3 greater or equal to -7. And if you solve it, here you're going to get the 2. Here you're going to get subtract 3, -10, -5. But then I get people that get confused. They are like, well, that's there, and there you go. But it's an and. So it's got to be this and this. So it's where they overlap. So it's only the part in the middle here. Whereas if you write it like this in the first place, you can really see that it does have a floor and a ceiling. It has a place the furthest down and the furthest up. Then it goes along with the picture much better. But there's not a damn thing wrong with doing this. Nothing wrong. Okay. How do you feel about that? Just remember, absolute value is distance. That's why I like to try to reinforce that idea. How do you remember what to do? This is distance less than something, so don't get far away from me. Here I am in the middle, don't get very far away from me. Whereas if it was a greater than, greater, so if I add, for example, some like, this is a stay the hell away from me. Right? I want the distance to be greater than something. So if you're closer to me than 5, it's not, I want it to be greater than 5 feet away from me. So then what does that look like? It's either, if this number is already bigger than 5, wouldn't the absolute value be bigger than 5? Give me a number bigger than 5. What's the absolute value? 6. 6. So if that number inside is already bigger than 5, then it works. But what negative number has an absolute value bigger than 5? -4. What's the absolute value of -4?
4.
Is that bigger than 5? No. See, it's not big negative enough. Because what's the absolute value do to a negative number? It takes its negative sign off. So the remaining piece has to be bigger than 5 for it to work. So that actually has to be less than negative 5. So when you take the negative sign off, you're left with a number that is bigger than 5. What's the absolute value of negative 7? Which is bigger than 5. So that's why the other case makes sense. If this number is less than negative 5, that will also work. Because when you take the negative away, the remaining number is bigger than 5. But I like the idea that it's either go up to 5 and go past 5, just stay the hell away from me, or go over there to negative 5 and go past that, down that way, stay the hell away from me. Greater than 5 or less than negative 5. Just stay away from me, I'm in the middle. Yes? Yeah, you create these two cases, and each case gives its own answer. We've seen where it might not give an answer in some cases, or it might give an infinite number of answers. But normally you're going to have one answer from this, one answer from that, one set, one. So like what would happen here?
Add 3
Add 3.
and divide by 2.
Yeah, divide by 2. Add 3. Not divide by 2, just divide by 4.
Divide by
Oh
4.
wait, less than negative 2, and then divide by 4, you get what? Negative 1/2. I like it. Now why didn't I have to flip the sign anywhere? I didn't divide or multiply by negative. It's only then. Right? Don't say there's a negative in the problem. I didn't divide or multiply by negative. So don't flip the sign. So then this has got to be greater than 2 or less than negative 1/2. So there's that idea of stay away from me. I like it. So if you try to make it look the same format, this or that, this and that, I understand that. You could do that. That works. It's just that I always hated, students will get very confused about and or and all that kind of business. Yes?
Yeah, I'm kind of confused. Okay, so for and, it's gonna have brackets?
No. What's the only reason this had brackets? It was a lot of equal.
So if you're gonna have it, it'll still be a bracket this.
It would be parentheses, yeah.
And,
This one, see? Does this have equal to? So it's parentheses. That's it. Yeah. Doesn't matter about or and that doesn't matter.
why is it a bracket though?
That's the symbol we chose. And I told you, I kind of gave you a way to remember why it's a bracket. It took the place of a closed circle from back in the day. So we had to use, so didn't we used to use closed circle and open circle? Right? So open circle looks like a parenthesis if you take half of it away. So that's why it's a parenthesis if it's not included. What's the first letter in include? I. Bracket. Right? So there you go. Why is that the choice? I don't know. I wasn't around when they first came up with it. In my brain, this is hard, so it includes it. This is soft, so it doesn't ever get there. That's the way I kind of look at it. Yep.
So a less than inequality will always have one set of, like one answer, and then a greater than will have 2 points or whatever.
Yeah, this will always have one. I'll be careful with this. Not always. There are extreme situations where it's all real numbers or no solution. But if there is kind of like a solution, it's going to be one set. Over here, it's going to be 2 separate sets.
Okay.
Yeah. Yeah.
How do you know if the equation, if you're gonna have to use an and or?
There you go. Yeah, well, again, that was this whole silly thing here that I don't like, but still it's useful, I guess. Less than. So you use an and when it's less than. So how do you remember that? Less than. Use an or when it's greater. Yeah. I don't really enjoy those too much, and some people see that as, yeah, you're a math guy, dude. That's some boring shit. You don't like songs and all that. But to me, it kind of makes it seem like math requires that. So a student starts to say, well, if a teacher doesn't give me songs and little sayings and little things, then they're not a good teacher, when actually it's just you get further removed from the math. You start to rely on the songs, and you forget why it works. Might just be me. I don't know. But too bad. Okay? Yes?
Can you finish 2A?
Which one was 2A? Yeah, let's see here. So I don't know which way you like better. I mean, I really would love it if the more you guys got to do, just do this automatically. So it's that and that, so you can put it together. I like it. Okay. And then you just, yeah, and then you're done. So what's that look like visually? 3 to 7. And then that's basically what it looks like, plus interval notation. 3 to 7. Bam. Yes?
Why is it a negative 2? Do you have to do that? Like,
Yes. Yes. Okay. So absolute value. What's the absolute value of negative 1? Is 1 less than 2? Is 1 less than 2? Yes. So therefore, negative 1 should be a part of, what did I just say? Absolute value of negative. So whatever makes this negative 1 should be a part of the answer. So can x be, so like negative 2, if this was negative 2, then it would equal 2 when you put that in there. Let me see, how else do I want to say this? Since it's an absolute value, that means that if I put a negative in there, the result can come out positive, obviously, right? It has to come out positive. So to keep it less than 2, I can't put, I really want this to make sense, to keep the result less than 2. What's the absolute value of negative 4? Which is bigger than 2. So I can't let it get to negative, and I can't let it get to positive. So there's only going to be a little area in which it's okay. So if I made it bigger than, if I made this number bigger than 2, it wouldn't work, obviously, right? If I put a 3 in there, that's obviously not going to work. But if I put a negative 3 in here, absolute value of negative 3 is 3, that's bigger than 2, not less than 2. So that's why I have to stop it. I can't let it go below negative 2, or otherwise the absolute value makes it bigger than 2. And I can't let it go more than 2. That one's a little more in your face. So what can I put in here so that the result is less than 2? I can't put negative 3 in there, because the result would be 3. Say again? If I put a negative 3 in there, is that true? Because what's the absolute value of negative 3? 3. So I really want you to see, why is this not allowed to go below this? Because if it did, and I took the negative off, which is what the absolute value would do, it would not be less than 2 still. It would be bigger than 2. That's why it's contained. I can't let the number piece, not the sign piece, but the number piece can't be bigger than 2. So negative 5 won't work because 5 is bigger than 2. And it's kind of the opposite idea with the greater than. I can't let this number, the number piece, be less than 5. Right? So that's why it's got to be greater than 5 or less than negative 5. I can't use negative 4, because what's the absolute value of negative 4? 4, is 4 bigger than 5? No. Okay. Maybe. Yes?
Question. When you said that 1 would work, that should be part of the answer, but isn't the
No. Whatever makes this 1. Whatever makes this 1 should work. What makes this 1? 6,
Okay.
for
And that's
example.
in between.
Yeah, 4 makes this negative 1, which makes the whole thing 1.
Okay.
Okay. Okay, I like it. All right. It really is as simple as realizing that it means distance and then memorizing how to rewrite it based on that idea. So I don't like to teach straight up memorization of anything. But once you understand the idea, if I have something like this, what do I have to do first? I think one of the problems is sort of like this on the sheet. Yeah, sure. Okay.
Subtract 4,
Subtract 4.
divide by -1.
Yeah, you got an absolute value totally by itself. So divide by -1, what happens?
So it flips.
Yeah, that flips. That's why it's important to first get the absolute value by itself before you figure out what situation you're in. I'm not in a less than situation, am I? I'm in a greater than. So is this going to be stay close to me, or is it going to be stay the hell away from me? Stay the hell away from me. So either I need this number to be greater than or equal to 6, or I need this number to be less than or equal to -6. So I want you to realize something. If I have like the absolute value of x less than or equal to 5, that would be this stuff. Right? Now watch. If I have I think I have one more marker that's actually working. Yeah. If I have the absolute value of x greater than 5, that's everything that this guy left out. Because you could either be less than or equal to 5 or greater than 5. Does that make sense? How old are you, kid? You're either less than 5 or you're less than or equal to 5 or you're greater than 5. You can't be something different than that. So whatever this guy leaves out, what this guy leave out? All this shit and all this shit. So it's really cool to see that an and an or together is everything. So the and, the less than, will always be this piece in the middle. I want you to stay close to me. The or is always going to be this outside stuff. I want you to stay the hell away from me. So the greater than, out there. Yeah. So think about this. Which picture stays close to this? Which picture is less than a certain distance away from 0? This middle piece, right? That's why the less than is going to be the middle piece. Which one is more than a certain distance away? These guys are more than 5 away. More than 5. Okay. So it really reinforces that idea that absolute value is a distance measurement. So we want to directly use that in analyzing these kind of problems. Let me see. Oh, and the last two on number 2 were both kind of freaky ones. Right, if you do this one,
Oh, that's the all real numbers one.
yeah, because if you subtract 3 and then divide by -1, now look at what this is saying. It says the absolute value of some number is more than or equal to -5. Is there any way for the absolute value to not be more than -5? What's the lowest any absolute value can be? 0. So no matter what the shit x is, this will be true. So whenever this side of your equation or inequality is negative, you're in a strange situation. With inequalities, it could be all real numbers or no solution. Here, it's greater than a negative number. That's always true. Right? So this will be all reals. I think, if I remember correctly, 2D, was the other way around.
Yeah, no, so
Because you subtract 6 and you get -2, and this says the absolute value is less than negative. Can that be true? No. So whenever the number on this side, when you get the absolute value by itself, if that number is negative, you slow your roll. You go, wait a minute, this is a weird situation. Why is this one no solution? Because I don't care what you make x, the absolute value of nothing can be less than this. No solution. Like it. So it's building how to do a problem based on the idea of what's been used. That's what makes math easier and more powerful. Instead of memorizing things to do in every situation. Yeah.
So when it said negative, you said there's like no solution, right?
Well, I mean, this was a negative, but the answer is all reals. So when there's a negative on this side, after you get the absolute value by itself, you're in a weird situation. So here, why was the answer all reals? Because it was absolute value greater than negative. That's always true. This one says absolute value less than a negative. It's never true. So whenever there's a negative on this side, you don't make your cases. It's a specific situation that you should see the answer to without doing any more work. You just got to take a minute and figure out what situation you're in. Maybe. You could do all the work and get some answers to this one, but there is bogus. They're no good. Okay? Is that cool for that sheet there? Were there any other ones? And I think she barely, managed to get one problem looked at. And I want to talk about the idea of this next section. So at least in this next section, there's no absolute values, for the most part. Somebody remind me, exactly how does that work? How do I graph that? This is going to be kind of silly. There's no trick question here. Just how do you graph it? What do you have to definitely put down here? 2. Because 2 is the dividing line between answers and not answers. So I'm going to overanalyze this problem because we're going to go step up a dimension. Yeah, dude. Currently, how many variables are in this problem? 1. So how many axes do I need? 1. The minute I put 2 variables in here, I'm going to need an x and a y axis. So before we do that weird shit, let's really analyze what happens here. How do I cut this line in half? I do it at a point, don't I? So the point that I'm cutting in half at is 2. So don't argue with me that it's infinitely long, so what's half of that? But still, I can cut it in half at a point. And which way, of course, am I going to shade? Yeah, why? Because does 3 work? Yeah. Does 1 work? No. So one side, everything will work, and the other side, nothing will work. Now, you could just say, well, it's pointing that way, so I can shade that way, Jeff. But that's sort of a shortcut to the idea. And, of course, we use what symbol in here? Parentheses. I like it. Cool. Now, so what if I had this? What is x plus 2 by itself? If you graphed it, what does it make?
1.
No. What does x plus 2 make? If you graph it, what does it look like?
Horizontal. Vertical line. I don't know.
X plus 2. Straight line. It's got a slope of 1 and a y-intercept of 2. So it's not a special case. It's not x equals 2. It's x plus 2. So if I graph y equals x plus 2, I get a line. See, if I graph x equals 2 on the number line, isn't that just going to be point at 2? Why was this more? Because it was greater than 2, not equal to 2. Here, if I graph x plus 2, can you graph it based on what we just said? What's the y-intercept?
1.
Try again. Y-intercept. Yeah, 0, 2. And now the slope is up 1 over 1. Up 1 over 1. Down 1 back 1. Right? Now, the idea is still the same. It's just that if I have a plane, this is a plane. This is like an XY plane. Are you guys with me? Imagine it goes forever in both directions. How do I cut it in half? If I were to try to cut this in half, right? I would make a line on it to cut it. Does that make sense? So if I have a line, how do I cut it in half? At a point. If I have a plane, how do I cut it in half using a line? So it's still going to be the exact same idea. There's a dividing place. In this case, it's going to be a dividing line. On one side are the answers, on the other side are the not answers. Can somebody just give me, like if x was 1, how many y's work? If x is 1, what's this side? If x is 1, this is 3. What do I make y to make this true? 4, 5, 5.872466, right? I mean, how many y's work for any given x? An infinite number of them. So here, the dividing thing was a point, 2. And then I shaded that way because that's the place where they all worked. Here, the dividing line is a line, right? In fact, now here's what gets interesting. I want to shade the answers So do I want to shade the line? Are the y's allowed to equal the line?
No.
No, see that? So the equivalent in 2 dimensions, we don't make little parentheses everywhere, thank God. We make a dotted line. That's the equivalent of like an open circle used to be, or parentheses. That's the same thing. Now, which way am I going to shade? Well, pick a point. If there is one point that works, that entire side works. Because this is the dividing line between good and evil, or answers and not answers. So, for example, the easiest point to use
0, 0.
is 0, 0 if you're allowed to use it. When would you not be allowed to use it?
If it's
If
on
the freaking line went through it. That would suck. We have to use a point on one side or the other. So if I use the point 0, 0, does it work in this? Is 0 bigger than 0 plus 2? Is 0 bigger than 2? No. Since that point didn't work, no points down here work, so I shade this way. Now, and just to show you this, we will eventually get here, but I want to immediately show you the applicability of this. In real life, there are guidelines to live with it. So you don't want to put too much load on something because then it might blow up. That kind of thing. Are you with me? You don't have too many people in the elevator or else it's going to plummet. Right? Not a good day. So in real life, I can have multiple requirements. So it could say I have to be above this line, I have to be above this line, and I have to be below this line. So then this is my safe area. That's my safe area, right? So it could relate to weight and electricity and whatever else is going on in your situation. So it could even be like the wind velocity and the shear on the building and so forth so that nothing falls over. So if you're here, your little meter is going to go in the yellow and you're going like, oh shit, we're out of the safe zone. What's going on? So that's the real life applicability of this, is where is my safe area? So how do I make this kind of picture with being I have to have 3 equations, or inequalities in this case. And then I can see where is it safe to be. This is what is really used in real life. As it sounds like it's by engineers very often. Engineers use this kind of thing. But so do, electrical engineers, about to say, but still an engineer. So the nice thing with this, now some people kind of groan, but hopefully graphing lines is not a huge concern. So what if I had a problem like this? What you got, John? Let's do, yeah. What's the first thing I should probably do? Yeah, I should get this thing, I should solve this for y, so I can see all the parts of my y. Divide by -3. Come on.
Flip the sign.
Kick ass. Flip that sign because I divided by a negative. Yeah, the negatives cancel. So now I can see the slope and the y-intercept. Is this going to be a dotted line? No. How can I tell? I like it. One of my students a while back said, if you see a line, you make a line. Right? So since this is allowed to equal this, these are the y's that equal this and are greater, right? So then I can make it a solid line. So when does it have to be a dotted line? When it's not allowed to equal it. It's sort of like an open circle here. So what do I know about this line?
-2, the y-intercept.
Yeah, the y-intercept's -2.
Slopes 4 over.
Yeah, so go up. And then 3. And then it's going to be solid line. And then how do you tell which way to shade?
Test 0, 0.
Very often it's easier to put it in the first thing. Watch. This will be 0 minus 0. Right? Is 0 less than or equal to 6? So we call that a test point. 0 minus 0 less than or equal to 6. Yes. What is that? Go ahead.
So when we're testing a point, it's better to plug it into the original.
Well, I mean, either way it works. Is 0 bigger than 0 minus 2?
Yeah,
So 0 bigger than or equal to negative 2? Yes.
okay,
So it doesn't really matter. I just like to plug it back up in here so it's quicker.
okay.
What does that mean? So 0, 0, did it work? Yes. So therefore I shade this way.
And it could touch that, like the shading could touch the line.
Well, the line is solid, which means you're golden. So it's sort of like making it a bracket. It doesn't matter if you touch it. I know that you're including it. I like it. I want you to notice something. The way I do this, I don't use a test point. Y's bigger than this. So here's a Y in the line. Where are the Y's bigger than that? Up here. So you shade up. It's just that idea, when you get a really steep line, the idea of up and down is a little freaky. Looks more like left and right than up and down. Does it make sense? So this one, again, this one was Y greater than this, so it's going to be up. But if it gets really steep, up and down are weird. Okay? So here, you guys try this. Let's see. Sure. Yeah.
So when you shade in, you just look at the sign?
Yeah, if you're really comfortable with, I mean, if you had a line that was like this, do you see how up would be this way? Just barely, right?
Yeah.
So as long as you're cool with determining exactly what's up and down, it's sort of like being under an avalanche, and you're like, which way's up, which way's down? You spit, and you see which way it goes. If you're cool with that, then that's the quick way to do it. You don't have to use a test point. So I'm going to catch up to you guys a little bit. Let's see. So then you know the slope and the y-intercept. You can graph the... I always think of it like somebody's holding a piece of paper and I chop it with a sword or something. Right? You're going to graph where that cut would be, and you're going to figure out which side of the paper is to shade. So what do I know about this line? It's got a y-intercept of... I like it. And then I go down 1
3
over 3. You can ask, what kind of line will it be?
dash, and then just shade below it.
Yeah, so you can either use a test point, 0 less than 0 plus 3, that's true. Again, if it was false, I'd shade it on the other side. Or you can say less than, all right, this is easy to see. You can see up and down pretty well here. So less than would be down here. So what does that mean? That means any point over here, all those points work. This point, don't work. It's very direct. So let's look at the green book, because they have graphs made for us already. Make it a little bit easier on us. Thank you, Karen, for the use. We're going. I want to do one like this. What's different about this one? Yeah, it doesn't. Well, okay, it doesn't have a slope like it. It's one of those special cases. Anybody remember what y equals something looks like? Yeah, horizontal line. X equals would be straight up and down. The way that Alyssa said it makes sense. The slope here would be 0 because there's 0 x's. So that would mean flat. X equals something would be vertical line. So how do I graph this line, -4, and what kind of line will it be, solid or dotted? Good, dotted, because it's not allowed to equal. So it's going to be dotted line and -4, and then I want all the y's that are bigger than that. So I'm just going to shade up. Okay, I like it. So if you have just a y or just an x and they give you an xy plane, it's going to either be a horizontal line or a vertical line. So here's the kind I want us to look at now. Oh boy. They make a big deal out of this kind of thing, but I have a system of inequalities. The answer to this system is going to be where the shading overlaps. Yes, are you good?
Oh, no, I agree.
So the way you look at this problem is, you do this problem all the way, get it shaded. And then on top of that, you do this other problem. So there's 2 problems in one. Do you remember solving systems of equations graphing, where you graph one line, graph the other, see where they meet? So it's the same idea here, it's just that I'm going to have to shade, so the answer is going to be where the shading overlaps. Don't look at mine and say, how do you get there? You solve for y and then compare it to what I got. So obviously, if you still have trouble graphing lines, these are going to suck. If you forget to switch this inequality sign, that's going to suck a bit, because you're going to shade the wrong way. Try to catch up. This first equation, what's the y-intercept? Yeah, 0, 3. And then from there you go down 3. Over 2, I like it. What kind of line will it be? Dashed. And then whichever way you want to figure out which way to shade, You can either plug 0, 0, 0 less than 0 plus 3 is 0 less than 3, yes. Or you shade down from this one. So I just put a few lines. If you like shade it for real, it's going to get really messy at the end. Because I'm going to have to graph a whole other line and shading on top of this. So how do I graph this guy? What do I know about this guy? Yeah, -2. 0, -2 for this y-intercept. And then I go up 2 over 5. And again, it's a dashed line. And then I shade down. So can you see the area, the region that is the answer? See how these are like walls now? So my answer is this whole region here. See, there's 4 regions, 1, 2, 3, 4. This is where the points work in both equations. So see how that's getting closer to this idea I had up here earlier about where's my safe zone? So that nobody dies. Okay. See, of course they would be a freaky one. Man. Here, let me change this around a little bit. Everybody delete that second one. Let me make a new one. I like this. It's fun. Let's do this. All right. So you see that? Do those. Go ahead and graph that one. Graph that system on there. By the way, what's the y-intercept for this one? Good. When you don't see a y-intercept, it must be 0. That's the only way it doesn't show up.